A source can be a current or a voltage. So current voltage, again ideal voltage and practical voltage. Then ideal voltage is represented like this, Vs plus or minus, where the internal impedance of the voltage source is equals to a 0. That internal impedance in a voltage source is represented in series with the voltage between the two terminals A and B. So this is the internal resistance of the voltage source. The ideal current source is represented with the current Is, and the practical current source is represented with a parallel internal resistance of current source, which is infinity. For ideal source, for practical source, this is R internal of current source. So this is a practical voltage source and this is a practical current source. We can transfer the practical voltage source into current source as well as current source into voltage source. Let us try to know the relation between these two sources. Load of RL is connected between the points A and B. This is my load RL. Then the current is IL. Now the current in this circuit is given by the load current IL equals to the source voltage Vs divided by the total resistance, that is RIV plus RL. Since in a series circuit voltage is constant, we are taking the source voltage, and in this circuit if you write the current, that IL, if again here also I'm connecting a load of RL in between the points A and B and I'm having the current of IL, then IL is given by the current in this branch is equals to current in the other branch Is multiplied by the resistance of the other branch, that is RIC, divided by the total resistance RIC plus RIL. Since the load is same and the currents are same, then we can write this as Vs divided by RIV plus RL equals to Is RIC divided by RIC plus RL. And this is possible only when Vs equals to Is RIC and RIV plus RL equals to RIC plus RL, from which we can say that RIV equals to RIC, which is nothing but the internal impedance of the voltage source equals to the internal impedance of the current source. And from this, Is equals to Vs divided by RIC. For example, if you take this as 10 volts and Ri is 2 ohms, then the current Is in this source is given by 10 divided by 2, that is nothing but 5. The Riv is 2 ohms, then Ric is equals to 2 ohms. Substitute these values in the above formula. The IL is Ri is 5, so 5 amps into Ric is 2 and 2 plus 2. 10 by 4, nothing but 2.5 amps. In this circuit, the IL is Vs is 10 divided by RIV is 2 plus 2. This is also 2.5 amps. So we can transfer a practical voltage source into practical current source by taking the internal impedances of both the sources are equal. Simulation results. You can observe that 10 volts of supply is given, load voltage is 5 volts, and the current flowing through the circuit is 2.5 amps through the load resistance 2 ohms. After source transformation from the practical voltage source to practical current source, here you can see the 2.5 amps of the load current for the load resistance 2 ohms and internal resistance 2 ohms, so 2.5 amps. The total current source is 5 amps, which we found from the practical voltage source, that Is equals to 5 amps.